Business Calculus 5.2. We want to take the integral of this problem right here. So what I want to do is I want to take the denominator, which makes this whole rational, and I want to make everything into numerators. So this will be the root of x cubed minus x squared. This goes to the numerator. Right now the denominator has a positive 1 as a power, but as a numerator it'll be 3x to the 4th power minus 4x to the 3rd power, all raised to the negative 1 power. And there's my dx. Okay, now it's all numerators with powers. Okay, I'm going to treat this as my u. So let u equal 3x to the 4th power minus 4x to the 3rd power. Then du would be 12x to the 3rd power minus 12x to the 2nd power, all times dx. Now I'm going to factor out the 12. So now this implies that du is 12 times x cubed minus x squared times dx. You see that this is beginning to match this right here, the x here, the dx here, dx here, the x cubed minus x squared, x cubed minus x squared. One thing is we don't have the 12. So what I'm going to do is put a 12 in here. So 12, and if I put a 12 inside, I have to put a 1/12 on the outside. Here's the x cubed minus x squared, and the 3x to the 4th minus 4x to the 3rd to the negative 1 power dx. Okay, so this again is this represents my u. But this and this all represent du. So using substitution, we get u to the negative 1 power and du here, making all the substitutions. Now, the antiderivative of u to the negative 1 is the natural log of u, and then plus c. So now I have 1/12 the natural log of u. So we'll complete this by turning the u into the x terms. So natural log of the 3x to the 4th power minus 4x to the 3rd power on all this plus c. Okay, sorry about that. Okay, and this substitution finishes the problem. All right, number 9. Number 9, we want to take the the antiderivative of this function within here, x times the square root of x minus 5. And I want to convert this root into a power. So this will become x minus 5 to the 1/2 power dx. Okay. Now the x minus 5 is what I'm going to base my u on. So we're going to let u represent the x minus 5. Then that implies that the derivative of u would be 1 times dx. Du being basically dx lets me represent the dx here with the du, and the x minus 5 will be represented by u. The thing is, we don't have a representation for the x yet. So what I'm going to do is, since u equals x minus 5, this implies u plus 5 would represent x. So this x right here will be represented by u plus 5. Alright, so now let's go ahead and make all the substitutions. This is the x being replaced with u plus 5. This is the x minus 5 being replaced with u to the 1/2 power, and the dx being replaced with du. Now let's distribute the u to the 1/2 power across this, and we'll get u to the 3/2 power plus 5 u to the 1/2 power in du. And from here, I can start using my power rules for antiderivatives, which means I need to add 1 to the power here. This will give me u to the 5/2, and the reciprocal will be 2/5. Here, I'll add 1 to the exponent here. That will give me 3/2, and the reciprocal will be 2/3, and then plus c. Alright, now I'll begin to take the u's out and replace them with the x minus 5s. So this will be 2/5 x minus 5 to to the 5/2 power, and this will be plus 10/3 x minus 5 to the 3/2 power plus c. And now, for courtesy, I want to return everything to the roots forms with roots. So these two will become roots. 2/5 and the square root of x minus 5 raised to the 5th power plus 10/3. This will become a root as well. The square root of x minus 5 all raised to the 3rd power, and then plus c.